Good morning, good afternoon. Thanks for attending the Oracle Integration Partner Community webinar. I'm Jürgen Kress, part of the product management team. In case you missed one of our webcasts, on-demand recordings are available at Oracle Video Hub, including presentation for download. In today's presentation, Antony Reynolds will present best practices for Oracle Integration Suite. Good morning, Antony.
Good morning, Jürgen. Thanks for a chance to present again.
So this is part 2 of the series. What are you going to present today?
So today we're going to talk about how to secure network access to your Oracle integration instance, and we'll touch a little bit on some of the monitoring as well.
Cool. So really important topics if you would like to run Oracle integration. What did you miss in part 1 in December?
Okay, in part 1, we talked about the things you should do when you create an Oracle integration instance. What are some of the choices you have? Which choices, if you make them, you can't change, and which choices you can alter after you've created the instance, and all the things you should do to make sure that your instance is easy to manage and secure and works well with your DevOps.
It's available on demand and you can watch it at Oracle Video Hub. SaaS services like ERP, HCM, and CX need to be connected. Oracle integration offers certified adapters and pre-built connectivity. Objective of today's call is to support you to build better Oracle integration projects. Please pay attention to the safe harbor statement. Quick housekeeping. Please feel free to post your questions via the conference Q&A tool. At the end of the webcast, we will answer them. Slides will be available at the Video Hub channel and community website. Please share your feedback via the Zoom survey at the end of the webcast. For today's agenda, after my quick introduction, I will hand over to Antony for the best practices with Oracle integration presentation. In case you missed our quarterly product update webcast, please watch it on demand. In the webcast, Greg Pavlik, our GVP for Oracle AI, will give a strategy update. Nathan Angstead will present the latest features and functionalities in a live demo. Please watch the webcast at bit.ly OIC December 2025. In the next webcast of our success series, One Globe will present with UCAL a success story how to implement Oracle integration RPA functionality. Please join us on February 18th. To get started with Oracle integration, we continue to offer the 3-day hands-on integration bootcamps. The training is suitable for SaaS consultants and integration developers. Upcoming schedules include Asia and EMEA in February and US and LAD in March. For partners, we offer an incremental training to get started with hands-on training on Oracle Agentic AI. Master the AI functionalities, including large language models and LLM and MCMP server in Oracle integration. We offer schedules for NAS and LAD and EMEA and APAC. For details, please visit our blog. Customers who are interested in the Oracle Agentic AI functionality can join the Early Adopter program. Jointly with you as a partner, we will build a proof of concept nominated by the customer with training and coaching sessions. We will present the success in webcasts and at Oracle conferences. Please nominate your customer, including the business case they are interested. All information, events, technical details is published in a monthly newsletter. Please read the January edition and subscribe to the newsletter. Today's webcast is recorded and will be available on demand, including presentation slides at Oracle Video Hub. With this short introduction, I would like to hand over to you, Antony. Thanks for presenting.
All right, so what we're going to talk about today is continuing the best practice series, but looking at how we secure access to our OIC environments. So as we go through with OIC, we remember that it offers a number of different capabilities, And what we're talking about today applies pretty much to all the capabilities. And we're going to be focusing particularly on the governance and compliance section here, where we'll talk about how to control access and how to monitor what's going on. So with that said, in order to be successful with AI, we need to have our apps connected, we need to trust the data, and we need the intelligent automation that Oracle integration offers us. And so Oracle integration is a key part of your AI strategies. And we've talked about that in the past, and we will talk about it again in the future as to how AI enables you to be a force multiplier with the integrations you already have. So we've really got two key areas we're going to talk about. We're going to talk about how to secure the network access to an Oracle integration instance. And we're going to talk a little bit about some of the security and monitoring associated with that. So let's start off with the network access. So let's begin by talking about what are all the different components that are exposed on the network with an Oracle integration instance. And a number of additional components may be exposed, but they will ultimately go through these same paths. So let's start off looking at what do we actually have in an Oracle integration instance. It effectively, we have two key components. The first one is the runtime. So the runtime is where your integrations execute. So when an integration runs, whether it's a scheduled integration, whether it's polling, or whether it's invoked, it always executes in the runtime, and people initiate them by sending messages to the runtime environment. That runtime environment, in turn, will talk to the internet through an internal NAT gateway that runs in the Oracle Service Network, or you might connect your instance to a private subnet, in which case the traffic can be sent for specific connections onto the private subnet and will never traverse the internet. We should probably point out here, because it's a question that gets asked at least once a day, is if I'm targeting another Oracle hosted service, will my traffic go over the internet? And the answer to that is no. Within OCI, we will route within the OCI internal networks, even if you're going to another internet address that is hosted in the same region. And we will, in most cases, also route the traffic to other regions over private Oracle connections. So just so that you're aware that just because it's an internet address doesn't mean that you are necessarily going to the internet. So that's the runtime environment. The design time is actually on a separate endpoint. And you'll notice that when you log in, that if you try to access the design time with the runtime endpoint, it will automatically redirect you. So the design time sits there alongside the runtime, has a separate endpoint, and we'll talk about some of the consequences for that later in the session. We also, if you have a file server enabled, that gets a third endpoint. And these two endpoints are HTTPS. So these are TLS protected endpoints. This one is typically SFTP. And so because it's SFTP, it's under the covers an SSH connection. So we'll be using port 22. And we'll talk about how you can actually get it to use port 22 rather than the random port number that is assigned today. Finally, the other network access we need to worry about is the OCI console and the OCI API. So this is primarily used for provisioning instances, but also some of the monitoring data can be stored there, and we'll talk about that later. So let's go through now and talk about how we can limit access, because this shows us a standard configuration where anybody can access these instances potentially. Now, if we want to, we can apply an access control list to the runtime and the design time. So at the moment, there is one list that covers both of those. We will be providing the ability to have separate ACLs for the two environments going forward in the future. There is a separate access control list for the file server. So let's just see how we could restrict access on these environments. So if we were to go in here, we can see at the moment this is an OIC instance. And if we look at the networking here, we'll see that it has no restrictions on the access. And so in order to restrict access to it, I would go in here, say edit, say restrict network access. And the key things is if I want to restrict access to both the file server and the runtime and design time, I can choose this option. And then I can provide an IP address or a subnet in here. If I want to just do the design time and runtime, block access based on addresses, then I can do that here. I can also restrict it based on virtual cloud networks or virtual cloud network OSID. If I choose a virtual cloud network, I can actually go and navigate and it will find one for me. If I just want to put the OSID in, I can do that as well. The file server, notice, can only do an IP address currently. We are working on being able to allow list based on VCNs. We need to make some protocol changes to do that. So to restrict access to the file server, we can do it based on the IP addresses coming in. Notice that there is a limit of 15 on the number of file server rules and the number of HTTP server rules. So that gives us a strict limit on the number of allowed listed subnets or IP addresses we can have. And so that can be a bit of a restriction. And we'll talk about how we can get around that restriction in the next couple of slides. Note also that in this case, I've got a custom host name, which is Oracle managed. And just to remind you of the behavior, if I put that in there, it will automatically, you see, it's redirected me to the design time. Notice up here, the address has changed. And we'll talk about some of the complications this brings in a few minutes. So we often want to have more than 15 IP addresses in allow lists, particularly if we're doing B2B with a large number of endpoints. B2B goes over the HTTP or file server traffic. We typically want more than 15 of those. So how do we do that? Well, what we can do is if we go back, let's go back to the slides a second. So we can actually front the components with a load balancer. And so in this case, we create a virtual cloud network, a VCN. On that VCN, we create a public subnet. Why do we want a public subnet? Because if we want the load balancer to be accessible from the internet, we need to have it in a public subnet. What we can then do is we can attach load balancing or put in network security rules on the load balancer to restrict it to specific internet addresses that are allowed to come in. There we can typically have a couple of hundred IP addresses allowed. So we can have much longer access control lists to limit the number of people that can access the load balancer. We then set up the runtime and the file server so that they only accept input from the load balancer. If anybody, although these still have public IP addresses, any traffic that arrives to them that does not come from the load balancer will be rejected. For now, let's ignore the design time. We'll talk about that in a minute. So, what do we do here? Let's have a look at the load balancer. So the load balancer typically will be listening on an HTTPS port. And so because we have to have a custom endpoint to make this work, it has to be customer managed. So let's quickly look at that. If we go into OIC1, go to the networking, first thing we notice is that we've got a customer managed custom endpoint. And so this is oic1.dev.oracleoic.com. So that gives us an endpoint that is unique, and we've said that we're going to manage it ourselves. So let's actually look at where we implement that endpoint. If I can. Okay, go the long way round. Just go up a level. So if we look here, I've got a load balancer set up. If I look at the listeners, I've got a listener for my file server listening on port 22, and I have listeners for my OIC instance. So let's go and look at the host names that I've got associated with it. So I've associated with it a OIC1 dev oracleoic.com. So I have that host name, and in this case, I had to provide a certificate for it. And so in the certificates and ciphers, we can see that there's an OIC1 bundle here where I include all the dependent certificates. And then there's the certificate itself for my OIC1 host name. When you're doing this, you can actually use the certificate service to store the certificates. And we won't go into that now, but that's what I did here. All these certificates are actually in the certificate service, and it makes it easier to manage them, easier to rotate them. So now we have our own certificate for OIC1 loaded into the load balancer. All traffic, when we put in the OIC1 hostname, will go to the load balancer. And then the load balancer has a backend set that talks to the runtime or the file server. So that's our basic configuration. If we look at this, we saw the listeners for the file server and the runtime. And then if we look at the backend sets, we can see that we have our OIC1 server and our OIC1 file server as two separate backend sets. So let's go back to the presentation. There's another thing that we can also do here is that if you want to increase the security, so this talks about limiting the inbound traffic. We've talked about now for the runtime and the file server, all traffic has to come through the load balancer. If it doesn't come through the load balancer, we are going to reject it. When it comes to the load balancer, we will validate it against a list of access control to see whether you're actually allowed to access the load balancer. And so this gives us a very tight inbound access controls. One of the other challenges is that when we come to allow list Oracle integration in other systems, for example, we want to say, hey, Salesforce, we only want you to accept requests from Oracle integration, or Fusion Apps, we want you to only accept requests from this specific Oracle integration instance. In that case, what we need to do is set up a private subnet. Now, this potentially could be in the same VCN as our public subnet. So we set up a subnet on a VCN and we attach Oracle integration to it. And we talked about this in the last session, but just to quickly show what that looks like, we can go into the integration. We need to change the compartment. So we'll go into our development compartment. And if we have a look at OIC1 here, we'll see that on the networking, it's attached to a private subnet for its private endpoint. What this means now is that for a large amount of traffic, I can say, hey, use the private endpoint, and even if it's internet traffic, it will be routed to the private subnet. On that private subnet, I can have a NAT gateway. And that will then route to the internet, and I can put my own rules in. Now, there's a couple of benefits here. One is that I can tell this NAT gateway, I can set the rules up so that only certain IP addresses can be accessed on the public internet. So that helps to prevent exfiltration of data. And we will shortly, later this year, be releasing a feature where all traffic is forced over the private subnet, and that will allow you to strictly control any exfiltration of data. Secondly, the reason that you want to go through this custom NAT gateway is that it is a unique IP address for your corporation. You can have multiple OIC instances using it, but you can say, hey, nobody else is using this IP address. Whereas the regular gateway is a regional gateway shared with other Oracle integration instances. And so instead of having it restricting access to anyone in the region, we can restrict it to just our company, or you can tie it down with multiple NAT gateways and say just this specific instance. So again, it tightens up the outbound security as well. Okay, so that's talking about the runtime. We've talked about access control for file server and runtime. However, that doesn't work for the design time. You cannot today, we're working on how to add a custom host name to the design time, but today you cannot have a design time custom host name. Remember when we went to OIC2? It automatically redirected us. If we, let's open up. So we went to OIC2, you see here, it automatically does a redirection, and this is not an OIC2 host name. And then we see we identify the instance with a parameter. So this is a problem because how do we tie down access to the design time? Right, so the way that we can do this is by using In my case, I've used a VPN, but we can route all traffic through a customer VCN. So in this case, I've installed a VPN server. I've added, in addition to the load balancer, I've said any traffic that comes from my own VCN, I'm going to allow access to the runtime, the file server, and critically, the design time. The design time will never see traffic from the load balancer because it's not a custom endpoint. But you can restrict the traffic to say only accept traffic from the local network. And so let's look at how that works in reality. So let's go. We saw with OIC1, it nicely redirected for us. Don't worry about the /DT, that's just due to some additional features we'll talk about later. So let's say I want to go to the design time. I immediately get not authorized, not found. So you can see that I have been redirected to the design time instance. It does have the right integration instance on there, but it's telling me to get lost. Authorization failed or requested resource not found. Let's have a look at the networking. So if we look at the network access, this is the IP address of my load balancer. Any traffic that came from the load balancer is allowed access to the runtime, the design time, and the file server. But as we said, design time will never get traffic from the load balancer. So how do we allow access to the design time and restrict it? In this case, we've actually got a virtual cloud network that we've said, hey, this virtual cloud network is allowed to access the runtime and the design time. So we've just seen that that at the moment we've got no access. So let's go and connect. Let's go to OIC1. So this is exactly the same URL we entered last time. Oops. But this time you notice that the design time is loading for us. So exactly the same target host name, the design time host, and the parameter is exactly the same parameter that we had before. So here you see we had the error failure. This time we go in and it allows us access. Let's close a few of these so we don't get confused. Okay, so let's go back and say, okay, so what happened there is that I have routed my traffic over my VPN client into the VPN here. Within the VPN, it has on the network, it has routing rules to say, hey, when you come in, forward it to the design time. Now you can do this not just with a VPN, you can do it with Fast Connect. You can do it with any of the several different ways in which you can connect into an OCI VCN. What is important, though, is that you need to engage your networking team, because if, for example, you've got a Fast Connect going on here and with private peering so that you're dropped onto a VCN in your OCI tenancy, you need to make sure that your networking team adjust their boundary routing protocols, BGP, to make sure that the public internet address of the design time is routed over the secure connection and not over the public internet directly. Because if it goes from here around to the public internet, you'll be bypassing the VCN and you'll be denied access. So this is how you can control access to the design time of Oracle integration. So the key thing is that we're routing traffic to a public IP address over a secure connection. That could be Fast Connect, it could be a VPN. And then we only allow access to the design time and the runtime from this particular VCN network. And so that gives us very clean, very simple network rules within the OIC. You see here, we've just got two rules. Allow the load balancer to talk to the runtime and the file server. Allow this network to talk to the design time and the runtime. So that's great. So now we've allowed access, we've restricted access to specific IP addresses, but how would we restrict access to specific integrations? Is there any way that we could do that? So let's look at the next slide. So you can see we've been building up a little bit at the time. We started off with a naked instance. You can have an Oracle managed custom endpoint, but all your allow listing has to be done within Oracle integration, and you have a limit of 15 file server and 15 runtime/design time access controls. We can use a customer managed custom endpoint, assign that to the load balancer. That gives us restricted access with up to 200 access control list items or more, depending on how you set up your rules in the load balancer, in the network security groups, in the VCN. Also, I should point out that this also allows you to start adding rules in terms of, hey, I only want traffic from this geolocation, for example. And so you can start to do additional rules. You can start looking for injection attacks, all kinds of things that you can do by adding web application firewalls rules that the load balancer supports. And finally, we restricted access to the design time by forcing all traffic over this VCN and limiting access to the design time to just this VCN. So now what we want to do is extend that and say, hey, what I'd really like to do is restrict access to the runtime to specific integrations. And so how do we do that? We introduce an API gateway into the picture. So in this case, I've put my API gateway behind the load balancer. You do actually have a choice. You could replace the load balancer with an API gateway. Note the API gateway does not support file server, doesn't support anything other than HTTP traffic. But you could replace the runtime access with an API gateway. In this case, I've chosen to centralize everything in the load balancer and then route traffic to the runtime through the API gateway. So once I do that, the next thing that I can do is configure it for fine-grained access control. So what I do is I say, okay, I'm going to allow different customers to, or different clients to come in with different OAuth tokens. The API gateway will validate the OAuth token that it's allowed to access. It will call an OCI function In this case, we've got an OCI function written in Python that says, okay, I've got a validated OAuth token. Let me check the scope. Okay, the scope says that you are going to access this particular integration or this particular project. Let me match that against the URL. Yes, the URL says you are going to that project. The OCI function will then generate a new token for you, send it back to the API gateway, and the API gateway will forward the request to the integration. So this allows us to have different OAuth tokens giving different access to the runtime. We continue to send the design time traffic through the OpenVPN. So in this case, we modify the access control lists for the runtime and design time so that instead of the load balancer, they're now only accepting traffic from the API gateway. And sorry, stop. Apologies, the robot is trying to clean my office. So hopefully not too noisy. All right, so now we entered the API gateway. Let's have a little look at how this works. So if we go back in the OCI console, go into the API management, and here I have an API gateway. So we have an example of these. Most of these were just test ones. You can see we've got a couple of different pass-throughs. So one is if I go through with IC API, then that's the one that I actually am trying to access the OIC instance with. Because I have that rule in, I had to introduce one to say, hey, redirect to the design time. So I put that /DT in there as well. So if we look at this deployment, can see we've had steady number of requests going through it, and we can actually edit it to say all the particular rules that are in there. So we can add rate limiting, etc. We can also look at the authentication, the routes. And when we go through the routes, we'll see that we actually added single backend, and we are using, so we've put in the backend explicitly. We're passing in the path and the details there. And then we have a number of different policies that we could add to validate things. So there's a lot that we can do within the API gateway. And so if we go back here, the key thing is this OCI function, so that when we come in, we do the token exchange and we can pass through and authenticate. So with that said, I think that covers us for the access control, except for one last thing I'd like to talk about is Oracle at the last AI World made a big announcement around zero trust packet routing. Those of you who have played with Oracle VCNs know that getting your routing rules and your network security groups all set up correctly can be complicated and difficult. Zero trust packet routing extends the OCI trust nothing by default model and gives you a simplified declarative model for establishing that security. And so basically, you set up a security model, you deploy your policies, and you apply attributes to specific devices. And so let's have a look at what that means. So first of all, let's quickly go to my integrations. Let's have a look at this integration, you notice that there's a security tab, and you'll see this tab in a number of different environments. And so in this case, we haven't used it for this particular instance. But when you add a security attribute, for example, Enterprise OIC, I could add that in to say that's the namespace. Then I can say, okay, production is true. So I could say this is a production instance. So what does that do for me? If I go over to, yeah, there we go. Within my zero trust packet routing policies, I can see, okay, in the enterprise OIC environment, VCN, allow development endpoints to connect to development endpoints. In other words, I allow non-prod to talk to non-prod. Similarly, and let's just go through, see where we actually set this up. So if I go into the networking, into the virtual cloud networks, you see it's got the same security tab. So it's got some security attributes down here. And so in this case, I've chosen the namespace, Enterprise OIC zipper. And I've said the environment for this one is the Enterprise VCN. And so that equates to the policy that we were just looking at, where in Enterprise OIC zipper environment, in other words, in my Enterprise VCN, I can allow anybody that's marked as development to connect to anybody else that's marked as development. Similarly, production to production. If somebody is marked as production and I try to connect to them from development, I will be rejected. And the zipper policies will automatically implement the right routing and access control list rules so that you have a simple policy and you don't have to worry about what all the IP addresses, etc. are. Now, if you want to, and as an example here, I've done a manual override and said, well, you can use IP addresses in here, but it's not as nice. You know, it's much nicer to just use these security attributes. And just to show another example of those security attributes, if I go to the load balancer, because the load balancer supports is for development purposes. So I've set the development attribute to true. It means that this load balancer won't be able to connect to anything that's got a security attribute of production. And so that's how you can make it very simple to see, okay, what are the attributes, and then tie it back to your policies. And so we saw these two policies allow development endpoints to connect to development endpoints and production endpoints to connect to production endpoints. It's a great way to simplify your networking rules and your network security groups is to use zipper. Okay, we're beginning to run out of time. Let's talk a little bit about performance and monitoring. So first of all, we highly recommend that whenever you're talking to OIC, you use OAuth. It helps to reduce the load on the identity service. It also means that we never see passwords passed around or hashes of passwords. We only see the tokens obtained from the identity service. in order to boost performance, we want to think about the concurrency as well. Based on the number of message packs, for each message pack you subscribe to, you get 100 concurrent threads, if you like, on sync requests and 50 on async. Now, in case you're wondering what that equates to, if you've got a 12-second response time, 100 concurrent requests will burn through a message pack in 10 minutes. So the concurrency levels are pretty generous. Schedule and async use the same concurrency pool. So schedule flows come out of the same 50 as the async requests. The suggestion is if a scheduled integration doesn't need to be a singleton, move it to an async integration to avoid blocking the schedule. You can do this by, for example, have your schedule run every 30 minutes, and the first thing it does is kick off an async flow. We see some customers do this very effectively by they pick up a file that has, a bunch of orders in, and then they spin off async flows to process a subset of those orders in parallel. When you use parallel processing, it automatically counts against concurrency. So how do you find out what your concurrency is, and how do you not identify that you've got performance problems? And so in this case, you want to have some monitoring to see what's happening. And so our recommendation as a best practice is to send your activity stream data to OCI logging. And so then within Oracle integration, of course, we have monitoring at the project and at the integration level. However, if we send it to OCI logging, we can attach alerts to it. So for example, we can say, okay, what's the average response time of this integration? If the average response time over the last 5 minutes is more than this value, raise an alert because that's breaching our SLA and we want to do something about it. So we can use alarms with the OCI logging to identify when a problem is occurring proactively, rather than waiting for our clients to tell us that it's taking too long. And just as a reminder, we talked about this in our last session, but very easy to set up the OCI logging. Just switch to the right compartment. Let's go and look within here. We see the logs tab, and we see at the moment we only have activity stream logs. We will be adding a couple more options in the future for the file server, the equivalent of an activity stream for file server, to say that somebody uploaded a file, downloaded a file, moved a file, deleted a file. And we'll also be adding the audit log in here as well, so that you'll be able to see that Antony edited this integration, Keyshaw updated this lookup. So we will be adding more categories in here, but for now, just the activity stream. So this is where you'd set it up. You'd choose the log group and then the specific log within that group. And if they don't exist, we will give you the option from within OIC to create the log group and the log name. At that point, you can decide what to do. And so we have options, for example, to send it to an Oracle database for use by analytics. You can put it into a storage bucket so that you just have very long-term retention for the data. If you're using Splunk, then OCI logging has integration to Splunk, for example, so you can send your logs there. The other important thing is that because you're now sending it to OCI logging, you can correlate it with other applications that are also surfacing service metrics or sending data to OCI logging. And so you can start building composite dashboards that include not just integration, but even Fusion apps, databases, custom OCI applications, anything that sends data to OCI logging, you can now create dashboards that combine it all. So that takes us through. Sorry, we went through a lot of heavy stuff. This was kind of a heavy duty, you have to pay attention session on this one. But at the end of the day, if you're going to connect your apps, automate your processes, and innovate, you need to have good security and good logging. And so thank you for attending. I can see that there's lots of questions that my colleagues have been answering. So thank you for that. And Jürgen, are there any questions that we perhaps should call out at this point?
Yeah, Anthony, thank you for the wonderful best practice session. So if you would like to learn more, please make sure you're a member in our community to attend those monthly calls. You can also visit the blog from the integration team. There's plenty of good information on the blogs for the SOAR community and for the integration team. Make sure you read the documentation and use the live lab material to get started. The live labs are hands-on trainings on demand, and all information is published under resources at bit.ly/links.org. So there are a couple of questions I would like to point out, and there are some open ones. So there's a question from Simon Haslam. Simon, are you here? Okay.
Let me unmute him.
I try to. So the question from Simon is, hi, Simon.
Hey Jürgen, hi Anthony. Yeah, just if we're going to tie down the IP addresses, because it's sort of done with Fast Connect with a separate team, I'm just wondering how stable that might be. Will be safe for a year or two or whatever?
Oh, we almost never change those IP addresses. So they changed when we went from Gen 2 to Gen 3. But they don't change otherwise. The only thing to watch out for is sometimes in large regions, we might add a new one. So that the old one will still be valid, but we might add additional ones. And so newer OIC instances might need to have a new design time IP added.
Okay. I had a quick look for the IPs. I haven't quite stumbled into the link yet, but if anybody has it handy, then please pop it. If not, I'm sure it's in the doc somewhere. Great. Anyway, thanks for that.
Okay, thanks, Simon.
So then there's a question from John Sullivan. He would like to know if there's additional cost for the load balancer that you can use for more than 50 IP addresses.
Okay, so the load balancer, you would pay the normal OCI costs for the load balancer. And so I don't remember the exact pricing on it, but it is not an expensive component.
It's like the
and you
API
can always
gateway.
go to the OCI pricing calculator to figure out what the costs would be.
Yeah, the pricing calculator lets you configure a whole environment, and on each product page you can see the pricing. So you go to Oracle Cloud Infrastructure, choose the product, and then you scroll down for the pricing page. There's a question from Michael. Would something like a caddy work as a reverse proxy?
That's a great question. I'm not really familiar with caddy, so all I can say though is that the design time is a separate URL. So so you would still have to route. If you were sending all your traffic through a reverse proxy, then in principle, yes, but that's no different to any other reverse proxy where you'd have to have the IP address of the reverse proxy in the allow list. And we did try this at Oracle once. The problem is we have so many offices and we do so much dynamic routing, is that even across a few requests, I found that I was being routed across different proxy servers, and I kept having to add more and more proxies, and in the end, it just got unmanageable. So very large corporations, it can be very hard to tie down all the proxy servers. In a
The
smaller
next
one
question.
where you've only got one proxy server, absolutely you could do that.
Cool. Then a question regarding the OpenVPN server, the split tunnel. Can you split the traffic or has all go through it?
Okay, so that depends on the routing rules that you have for your VPN, and it's the same with what Simon was talking about with the BGP. You can advertise specific public IP routes so that they are cheaper and it goes over the VPN or over the Fast Connect.
Then there was a question regarding training documents. Ravi Pinto pointed out the Live Lab material. Let me share that again. Go to Oracle Live Labs. You can Google that, and there you can search for basically all the Oracle products for on-demand training, which is hands-on. Really good stuff. It's also linked from the documentation page. Okay.
And so a good question by Anantha. I'm sorry if I mangled your name. Is it possible to log payloads in OCI logs without enabling debug? Yes, it is. There is the log activity, and we strongly encourage you to use the log activity to pick out the data that you want to save. And I see Ravi is just answering that in the Q&A now. But yes, you can use the log activity to log data without it being in debug mode.
Thank you.
And a question about, is custom endpoint in all versions of OIC? Yes, it is. And two flavors, Oracle managed, where we get the certificate for you, we manage it and we put it in our load balancers. Customer managed, which is what we focused on today, gives you lots of flexibility in adding API gateways and load balancers and really sophisticated traffic management.
Antony, you mentioned the other day there shouldn't be a webcast without projects. So what is projects?
Yes. And so I mentioned projects when I was talking about the integration level and project level access control. It makes a great deal of sense to say, hey, this client can access this project, and to set that up, you would need to be using projects. Projects allows you to have a single OAuth scope that covers multiple integrations. It allows you to group those integrations together. And so projects really does help you to manage the access control of your integrations in conjunction with API gateway and specific OAuth scopes. So thank you for the prompt there, Jürgen. Everybody should be using projects.
Also to get access to the new functionality like robotic process automation.
Exactly, and the AI generated integrations.
Ravi Pinto, you answered most of the questions, so thank you very much for that. Are there any questions you want to read out for the benefit of everybody?
I think Namit has posted one just now. Design time URLs not working with custom endpoint. I think Antony, you spoke about that a little bit earlier.
Yes, I think we covered that multiple times in the session that it's something that we're looking at in the future to have a design time custom endpoint, but that's not there at the moment. And so the only way that you can totally lock down the design time, other than listing all the client IP addresses, is to use restrict it to traffic coming from a VCN and then setting up appropriate rules for routing through that VCN.
Right.
Thank you very much for attending today's webcast. If you would like to contact the team, Neil Kominski is our product manager in EMEA, Paolo Mota in South America, Ravi Chaplani in North America, Ravi Pinto in Asia, Steve also in Asia, and myself for any kind of partner and marketing questions. Thanks for the team to helping us today with all the answers and the Q&A session. Here are the links for all the resources, so please make use of them. And we would like to say thank you for attending today's webcast. The next one is planned for February 24th, and please complete the online survey once you leave. Thank you very much.